I want to welcome you all to this video. Thank you for joining me. I am Mr. Ish. Here we will apply those two basic tests of convergence that we have learned with regards to perhaps 3 or 4 questions, starting here with this one. Always start with the basic test first and then confirm it if you want with the comparison test based on what we have learned so far. We are looking here at this. We have 1 over n factorial from n equals 1 up to infinity. If you were to expand this, you'd be looking at 1 over 1 plus 1 over 2 factorial, which is just a 2, plus 1 over 3 factorial, which is a 6, plus 1 over 4 factorial, which is a 24, plus 1 over 5 factorial, 120, all the way. When you're looking at this with regards to the basic test, you know limit as n approaches infinity. Do your terms generally tend towards 0? It seems like they do because everything is progressively getting smaller in terms of its mathematical value, and you will eventually see that you're going to progress and tend towards 0. If you were unsure with regards to this, and keeping in mind that the basic test with regards to convergence does not give you a 100% guarantee that it indeed is, you might want to apply the comparison test over here just for additional verification. With the comparison test, now you need to find something which looks like this in a certain form, and you can never be wrong utilizing something like this. 1 over n p, you're looking here, n equals 1 up to infinity, where p here is equal to 2. If you were to expand this out, now you're looking at 1 over 1 square, which is a 1. 1 over 2 square, because p here is equal to 2, 1 over 4, 1 over 3 square, which is a 9, and 1 over 4 square, 1 over 16, and 1 over 5 square, 25, all the way onwards. Now you will do item by item analysis, start comparing them. Is this smaller than this? This right here is your known standard, this right here is your test, your testing. This is not smaller than that, but it's fine. But when you start looking at the next one, you have 1 over 2, you have 1 over 4. We don't succeed, we fail over here. When we look here at this next one, right here, 1 over 6 and 1 over 9, we kind of see that we are still larger than that. However, from this point onwards, when you start comparing, everything starts becoming smaller with regards to your test. And then you end up seeing that in this particular instance, from this point onward, you will see convergence, and you would be right. So if someone were to ask you, is this a convergence series, you would say yes. The basic test hints you towards it, and the comparison test from this point onwards, from value here n equals 4 all the way up to infinity, you'll always tend towards 0, and you would indeed be correct. A convergent series exists over here. Let's look at this question number 2, n divided by n plus 2, a series from n equals 1 to infinity. We have to evaluate it for convergence. Remember, in these questions we're saying if something is convergent or not. If it's convergent, we're not determining the finite value, we're only applying the tests of convergence. If you expand this series out, you're looking at 1 over 1 plus 2, and you'll have a 3. The next one will be then 2 divided by 2 plus 2, which is a 4. And then the next one will be 3 divided by 5, and then the next one will be 4 divided by 4 plus 2, 6, and onwards. Look at these in terms of their mathematical values. Here you have a 0.333, here you have a 0.5, here you have a 0.6, here you have a 0.6667. You're having a general increase here. When you're utilizing the basic test over here, you're seeing that this is not coming into play. Limit as n approaches infinity, the last term or the series in general is not approaching 0. So this right here ends up being divergent, and you don't even have to bother doing the comparison test because the basic test with regards to divergence is accurate. You don't have to do anything with regards to that. We have a divergent series over here, and this question has been completed. We have a series which looks like this. We're not defining it in terms of any rule, but we have 1 divided by 1 times 2, 1 divided by 2 times 3, 1 divided by 3 times 4, and onwards. These numbers are increasing steadily by 1. You can see 1 times 2, 2 times 3, 3 times 4, 4 times 5. Everything here is with the 1 in the numerator. If you apply the basic test and you start looking at these values, you're looking here at a 1 divided by 2, 1 divided by 6, 1 divided by 12, 1 divided by 20. You have a general progression that the mathematical value of these are indeed getting smaller, and you would see that in general the series will tend towards 0, so you would see convergence. But I would want to confirm that because it would be a maybe over here, and I can confirm that with a comparison test. And again, you can never be wrong with utilizing something like this, 1 over n to the power of p, where p is equal to 2, and you would utilize this. When you utilize this and you open it up, you have 1 over 1 square, which is a 1 over 1, 1 over 2 square, which is a 4, 1 over 3 square, which is a 9, 1 over 4 square, 1 over 16, and onwards, as you see. So now start comparing this first several terms. When you're looking at 1 over 2 with 1 over 1, this right here is smaller. When you're looking at 1 over 6 with 1 over 4, this is smaller. 1 over 12 with 1 over 9, this indeed is smaller. 1 over 20 divided by 1 over 16, this is smaller. In all instances, the terms of your test are smaller than a known standard, which is defined to be convergent. Therefore, this series you have must be convergent, and you would be right. Remember, if you're looking at something like this, you know here you're looking at something which is convergent. 1 over n to the power of p, where p value here, as you remember, should be larger than 1, is an indication of a known standard that's convergent, and you can rely on this quite a few times. And this right here is convergent. Let's look at this as our last question. We have 1 divided by n squared plus 1, n equals 1 up to infinity. If you were to expand this out in terms of a series, you're looking at a 1 over 1 plus 1, which is a 2. Then you'd have 1 over 4 plus 1, which is a 5. Then you'd have a 1 over 9 plus 1, which is a 10, and then 1 over 16 plus 1, which is a 17, and then onwards. And you would eventually come down here to infinity. In terms of the basic test, you're seeing that these values are mathematically getting small. Plug them in the calculator, each of these values is small. You're seeing that limit as n approaches infinity based on the basic test. Your series in general is tending towards 0, so you can assume you have convergence. But if you want to have extra assurity and you want to use a comparison test, there's nothing wrong. Again, you cannot be wrong with utilizing something like this. N equals 1 to infinity, 1 over n to the power of p, where I'm going to put p here is equal to 2, because we know this is a standard series which is known to be convergent. Now look at this. You have 1 over n squared, you have 1 over n squared. Here you have a plus 1. This factor should automatically clue you in that you're looking at something here which will truly be convergent, because here the denominator will always be 1 more than the denominator generated here, because everything over here mirrors very well, except here you have a plus 1, so that automatically pushes your denominator here to a larger value, and everything over here is still a 1 over. Then you know your test series item by item will always be smaller with regards to the known standard items. Here you'll have a 1 over 1, here you'll have a 1 over 4, here you'll have a 1 over 9, 1 over 16. Here's my first item, here's my first item, and this is smaller. Here's my second item, here's my second item, that's smaller, so we're good. Third item, smaller. Fourth item, smaller. In all instances, the test values are smaller than the corresponding known standard values, which are proven to be convergent, so you know you're good here. The basic test pushes you towards convergence, and the comparison test confirms it to be convergent. And this right here was perhaps the biggest giveaway, n squared plus 1 versus just the n squared. And that's all I want to present to you in this video, the application of the basic and the comparison tests. Thank you for watching.